Hello, it's Dave Giles here again for the second lesson of Cambridge IGCSE Physics Unit 3 waves. And today we're going to be looking at different wave equations. So the first thing I want you to do is define and perform calculations on time period and related to frequency. And I want you to calculate the speed of a wave. And by the end of the lesson, you should also be able to use some of these key words. So period, also known as time period, frequency and wavelength, which we've looked at in previous lessons, and speed, which is a term you should already know from previous units. So frequency is the number of waves produced each second. Okay, so how many waves you get per second. So here, for example, we have 4 seconds. So how many full waves are there? So you can see here, go from there all the way down, back up. It looks like I've accidentally cropped the bottom of some of these waves out a little bit too much. But this here is 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 full waves there. So how many waves are produced in 4 seconds? That is 8. So how many waves are produced in 1 second? So 8 waves in 4 seconds. So that would mean that every 1 second we're having 2 waves. And we said frequency is the number of waves produced each second. So that means we've got a frequency now of 2 hertz. So that's just demonstrating what is actually meant by frequency. So period, also known as time period, is the time taken to produce 1 wave. And because it is time-based, the units are going to be seconds. So frequency is 1 divided by t, which is the time period, or period t is 1 divided by the frequency. So an example question, a wave of a frequency of 50 hertz, calculate the period of the wave. T is 1 over f. The 1 over 50, which is 0.02. And at the minute, we still haven't quite got a full answer there because we need to put the units, seconds. Okay, here are 6 very quick questions for you to have a go at. The first 4 are just calculations. The 5 and 6, a little bit of understanding is also required there. Again, as usual, I'll let you pause it, give it a go, and then when you resume, I will put the answers on. Okay, I'm just going to put the answers on for these because these are fairly straightforward. Okay. And that is the first learning objective complete, define and perform calculations on time period and related to frequency. The second objective for today was calculate the speed of a wave. So this is a new formula here. Wave speed is frequency times wavelength. Now, we use letter V for speed, for velocity, F for frequency, and wavelength, we use this symbol here, lambda. Wave speed is measured in meters per second, m/s. Frequency measured in hertz, and wavelength measured in meters. So a quick question, a sound wave has a frequency of 1,000 hertz and a wavelength of 0.32 meters. What is the velocity of the wave or speed? V equals f lambda, f is 1,000, lambda is 0.32, multiply them together and you get 320 meters per second. So it's going to put on twice by mistake, sorry. I'm just going to put 3 very quick questions for you to have a go out there. As usual, pause it, and I'll put the answer on in a few seconds. Yes, the first one's 325 meters per second. Next one is 0.66 meters. And the third one is 2.5 hertz. Okay, so now that's the second objective complete, calculate the speed of a wave. But so far, we've looked at fairly basic questions. So I'm going to put the 2 together the two learning objectives, which were calculate the speed of a wave for the second one, and the first one was define and perform calculations on time period and related to frequency, with these past paper exam questions here. So these three here are paper 2, and this is a paper 4 past paper exam question. As usual, pause it, and I'll review the answers in a minute. Okay, so I'll talk you through the multiple choice questions, and for the paper 4, I'll just put the mark scheme on. So a wave of frequency 13,000 hertz travels 1,300 meters in 4 seconds. What is the wavelength of the wave? So we're going to use the formula V equals F lambda. Now we've got the frequency, but we haven't got the wavelength here just yet. Okay. So we're also going to need to use an equation, which we haven't looked at today, but it's an old equation. Speed equals distance divided by time. So it's traveled 1,300 meters in a time of 4 seconds. So 1,300 divided by 4 seconds gives me a speed of 325 meters per second. Now, rearranging the V equals F lambda formula I mentioned earlier, you get lambda or wavelength equals speed divided by frequency. So 325 divided by 13,000 hertz gives me 0.025 meters. So the answer is therefore A. Second question, which statement about waves is correct? So let's have a look. Waves do not transfer either energy or matter. Well, they do transfer energy, so that's false. Waves transfer both energy and matter. That is false because they do not transfer matter, just energy. Waves transfer energy without transferring matter. That is true. But just for completion, we'll look at D. Waves transfer matter without transferring energy. They've got that the wrong way around. So the answer is C. And finally, the bottom one here, the bottom multiple choice question. A wave has a frequency of 10 kilohertz. Now, kilo means 10,000. So kilo means thousands, that means 10,000 hertz. Which pair of values of its speed and its wavelength is possible? So if we're looking at the formula, V equals F lambda, rearrange that to get frequency equals speed or velocity over lambda or wavelength. So if we do the first one, speed is 330 divided by, I'm typing this on my calculator, 330 divided by 0.33. In fact, I'll put the calculator on the screen. So it will be speed divided by wavelength. So the first one will be 330 divided by 0.33 meters, which gives me 1,000 hertz. So I know straight away it's not that. Next one will be 330 divided by 33 meters, which is 10 hertz. Again, it's not that, because remember, it's kilohertz, it's not hertz. The third one is 3 by 10 to the 8. Now, I haven't got this in standard mode, put it in scientific. Okay, so I've got 3 times, now I'm not used to using the on-screen calculator here. 3 times 10. Ooh, it's the wrong button on there. Clear that. 2 seconds. Okay, so I'm going to type it out the old-fashioned way. 3 with 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. Just because I'm not sure I use this calculator yet. I'm much more used to my own Casio, which I use in the classroom. Divided by the wavelength of 30 meters. So divide by 30, which gives me 10, a number much bigger than 10 10,000. So it is not that one. So hopefully it's going to be the last one, but we'll double check. So it's 3 by 10 to the 8. So that's 3 by 10 to the 5 at a minute. 6, 7, 8. And then divided by 3 by 10 to the 4. So 3, then 1, 2, 3, 4, which does give me 10,000. So therefore, the answer is going to be D. Okay. And then we'll have a look at the mark scheme for the last bit here. I'm just going to put the mark scheme on the screen now. That is the mark scheme. As usual, pause it and mark the question yourself. Okay, thank you very much, everyone. I will be posting the next lesson soon on the electromagnetic spectrum. Thank you very much and see you all later.